So we're talking about conic sections, and of them, which are their discriminants. So what is eccentricity, and how do we use the discriminant? What does that tell us about conic sections? Okay, so we have 4 conic sections, and we've been using the standard form of conic sections. Well, now we've got a little something new. We've got a general form for all conic sections. Okay, and here it is. All conic sections can be given in general form. Remember, with quadratic functions, there was a general form or a standard form. Now this is the general form of all conic sections. Okay, when we have the general form, there is an a in front of the x squared, a b in front of the xy term, a c in front of the y squared term, d in front of the x, e in front of the y, f, and then 0. All right, we can always determine the type of conic using the discriminant. The discriminant has not changed from the quadratic. Discriminant is b squared minus 4ac. So let's talk about what the discriminant tells us. If b squared minus 4ac is negative or less than 0, then we have an ellipse. If b squared minus 4ac is greater than 0, we have a hyperbola. If b squared minus 4ac is equal to 0, we have a parabola. And I know that you're thinking to yourself, well, what happened to the circle? Good question. Okay. Circles are a special type of ellipse. Circles, if the discriminant is less than 0 and a equals c, then we have a circle. Okay? So that's the deal. So that was a good question. I know you were thinking. Okay. So let's take our new information and classify the conics below. Remember, we first have to get each of these conics into the exact general form. So let's do that. Okay? So we start with a x squared, xy term, y squared, 2x. We have to pull this over, so it's x squared plus xy minus y squared plus, get the 2x minus 3. There is no y term, equals 0. So what do we have? We have a equals 1, b equals what? 1, c equals negative 1. Now all we need is the a, b, and c, so we don't really worry about anything else. So now we're going to figure out our discriminant. Okay, so we have b squared. Remember, b squared minus 4ac. So that's going to be 1 squared minus 4 times 1 times negative 1. So 1, a negative times a negative. So it's a positive. So 1 plus 4 equals 5. So for this conic, we know that the discriminant is greater than 0, so this is a hyperbola. See? A little bit of work, but okay. Let's do the next one. Okay, so we have x squared minus 4x plus y squared plus 2y. So we have an e term, but not a d term. Minus 4 equals 0. So let's sort this out. We have a equals 1. We have a b term. B equals negative. Nope, we don't have a b term. B equals 0. Sorry, b equals 0. We have a c term. C equals 1. And we don't worry about any of the other terms. Okay? So let's write out b squared minus 4ac. So we have 0 squared minus 4 times 1 times 1. So no b, so what do we have? A minus 4 times 1 leaves us with what? Negative 4. So our discriminant is less than 0, so we have an ellipse. All right. Okay, now we have to think to ourselves, well, is there anything special about this ellipse? There is, because does A equal C? Yes, A equals C, so this is not only an ellipse, it's a circle. Okay, so let's do another one. We have, now there is no x squared term, y squared minus y minus x. Let's subtract the 9 from both sides. Minus 4 equals 0. Okay, so let's look back up to our general form. We have A equals 0. There is no x squared term. B equals 0. And C equals positive 1. Okay, so filling in our b squared minus 4ac, we have b equals 0. So that is 0 squared minus 4 times 0 times a c is 1. But this is going to give us what? 0 minus, anything times 0 is 0. 0 minus 0, the answer, the final answer is going to be 0. 0 minus 0. So when the discriminant equals 0, what do we have? We have a parabola. And we know that number 3 is going to be a parabola. Okay, so we see how to do, use the discriminant to classify the conic, and there we have it. Hyperbola, an ellipse, and which is a circle, and a parabola. Okay, so let's move on. Eccentricity. All right, eccentricity and is, let me move this up a little bit. It's not a measure of character. It is a mathematical term that means a measure of how much a conic section deviates from being a circle. Deviates from being a circle. So I guess the perfect conic is a circle, and eccentricity is how far away you are from being a perfect circle. So we have our 4 types of conics and our eccentricity. Okay, if E equals 0, it's a perfect circle. If E is less than 1 and greater than 0, somewhere between 0 and less than 1, then we're an ellipse. If E equals 1, we're a parabola. And if E is greater than 1, so equal to 1 is a parabola, greater than 1 is a hyperbola. So here's a scaled example of increasing eccentricity. Perfect circle is 0, getting larger. Eccentricity getting actually more and more and more towards an ellipse. But between 0 and 1, getting more toward like an ellipse. If we get greater than 1, we're just going to break apart and become a hyperbola. Okay? All right, let's turn over. All right, our formula for eccentricity is very simple. Small e, by the way, small e equals c over a. And we have our formulas for finding a, b, and c, and we just use them. So find the eccentricity for this ellipse. We know it's an ellipse, okay? So how are we going to find this? Well, we're going to have to find c and a. That's all we need. All right, well, we're going to have to find c. Well, in order to do that, we're going to have to get this in standard form so we can find a and b, and therefore use a and b to find c. So we get the strategy? Okay. I'm going to have to complete the square. I know how to do that. 336x squared, gather all my x terms, minus 216x, leave a space, plus 4y squared, plus 32y, leave a space, equals negative 244. All right, I'm going to divide out 36. 36 times x, divide 216 by 36, and it leaves me with 6x, leave a space. All right, plus 4 times y squared, divide 32 by 4, plus 8y, leave a space, equals. Now, we're going to have negative 244 plus 36 times something plus 4 times something. All right, now we're going to finish completing the square. So down here, let's do complete the square work. How do we complete the square? Well, we take negative 6, we half it, and we square it. Leaves us with negative 3 squared equals 9. So we add positive 9, positive 9. Now we're going to take 8, half it, square it, equals 4 squared equals 16, positive 16, positive 16. So now I'm going to say what 36 times my binomial squared, x minus 3 squared, plus 4 times y plus 4 squared equals, I'm going to add all these together. So when I add all these together, this is 36 times 9 is 324. 4 times 16 is 64. And then I have a negative 244. When I add all this together, this is going to give me 144. So we know how to do this, right? What am I going to do? I can't have a 144. I need a 1. So I divide everything by 144. 144, 144. This gives me 1. This gives me 44 divided by 4 is 36. 144 divided by 36 gives me 4. Okay, so now I'm getting a parabola that, an ellipse that looks like x minus 3 squared over 4 plus, I know it's an ellipse, y plus 4 squared, 36 equals 1. I'm going to box that in so we can clearly see it. Okay, what is my a and my b? Well, I know that a, being the larger term, okay, is the square root of 36. A equals 6. B equals 2. That's what I needed. I did all this to say, if I have an ellipse, then I know that c squared equals a squared minus b squared equals 36 minus 4. C squared equals 32. C equals the square root of 32. I can break that up. C equals the square root of 16 times 2. So what is the square root of 16? The square root of 16 is 4 radical 2. C equals 4 radical 2. All right, we're getting there. So that is what I needed. I needed two things to find my eccentricity. E is equal to C, 4 radical 2 over A. I've lost my A. A is 6. So now I just have to reduce that one more time. So 4 over 6 becomes 2 over 3. So 2 radical 2 over 3. And that is the eccentricity of this ellipse. Okay, whew, that was some work. Okay, let's do example number 2. All right, a certain ellipse has eccentricity radical 5 over 3 and vertices at these points. Write an equation for the ellipse and graph it. So let's think about what we have. What do you have? You know the equation for an ellipse. You know that E equals C over A. You know that you have radical 5 over 3. So you know that C equals radical 5. You know that A equals 3. With C and A, you can find B. So let's find b. You also have these points, so that's going to tell you something as well. So first of all, let's find b. You have an ellipse, so you have a formula. C squared equals a squared minus b squared. So you have the square root of 5 is your c squared equals 3, which is a squared minus b squared. So what is radical 5 squared? That would just be 5 equals 3 squared, 9 minus b squared. Now I'm solving. Subtract 9 from both sides. This is going to be negative 4 equals negative b squared. Well, I'm just going to divide by 1 on both sides. Divide by 1, divide by 1, negative 1, excuse me. That becomes 4 equals b squared. Now I'm just going to take the square root of both sides to get b equals 2. Okay, so now I have all of my numbers. So what do I know? Let's now graph the points that we have. So I'm going to say my vertices of my ellipse. Now the fact that it says vertices tells me something. That's the major axis. So I have negative 1, negative 3. That's a vertice. And then I have 5, negative 3. So that tells me that is the long end. Okay? So now I know that the middle, the center of my ellipse is right between those 2 points. 1, 2, 3, 4, 5, 6. So the center of my ellipse is here at 2, negative 3. Okay? So we know something else about this ellipse. The center of it, the center is at 2, negative 3. And that gives me h and k, which is, what were we asked to do? Write an equation. We need h, k, a, and b. That's what we need to write an equation, and we have now everything we need. And we could draw it as well. If I have a b of 2, what do I have? I have the co-vertices, right? If this is my center, then my co-vertices are going to be 2 in the up and down direction from my center. Therefore, I can draw my ellipse. Excuse me. Not perfectly drawn, but there you go. And there we go. Now let's draw the equation. What is the equation for an ellipse? It is x minus h squared y minus k, which is plus 3 in this case. We know that the long end goes, the major axis is under the x squared, so that's going to be 3 squared, which is 9. This is going to be 4 because it's 2 squared equals 1. Okay, so there we have the equation for this ellipse. Okay, I want you to do example 3 on your own. It is almost exactly like example number 2, so go ahead and do that on your own and give it a try. All right, see you when I get back.